Hi everyone, myself Durga Appa Rao, working as assistant professor of CSE department in Vignan Institute of Engineering for Women. Today we are going to discuss about stack data structure. Actually, the stack data structure was implemented for storing the elements in the last in first out manner. Let us see. A stack is a linear data structure, and in which we are adding the elements in a one end. At the same end, we are able to remove the elements. Let us see some examples. So here are some examples, real-time examples. Let us assume that the chairs are arranged in a order, one above the other, right? So if you want to remove a chair from in this or in this case, if you want to remove the bottom chair which was placed at the first one, we have to remove all the chairs from top to the bottom. The same way, this is some other example, and this is also another example how we are storing the data into the stack. Let us see. So the main stack data structure will be seems like this. If you want to add some element onto the stack, we are adding the element at the same position, and we are removing element from the stack at the same position. Here the top here if you want to implement a stack, always the operations which is either push or pop operations can be done at top level of your stack, where initially the top is a variable. Actually, the top is a variable which is always pointing to the top location of your stack. The push operation, which is used to store an element at the top position of your stack, and if you want to call the pop operation of a stack, which removes or which pops element from the top of the stack. Let us see. Whenever the stack is created, the base element will be the remaining at the bottom. Let us see. As I said, if this is the stack, if you are inserting one element, the element which was inserted first will be at the bottom. That will be the base. Okay. And if you are inserting another element into the stack, so the top level will be incremented when we are inserting a new element into the stack. At the same time, when we are trying to pop element from the stack, the top will be decremented again. Okay, so this causes there is a chance of getting underflow condition as well as overflow condition. I will explain you in the next slides. Let us see how the insertion can be takes place in a stack. For example, let us take this is a stack. Okay, initially the top will be a -1 because I'm assuming that the stack was going to be implemented with the array. So initially the top position will be -1 and the stack is empty. And when I'm trying to add some element into the stack, we have to increment the top first. Then, so let us see how the insertion can be takes place in a stack. Let us assume this is a stack which was empty, and the top was initially -1. And when I am trying to insert some new element, first what we have to do, you have to increment the top, because the top is a -1, right? So -1 is index, so we have to increment the top first, then we have to insert a new element called 10. After, when I'm trying to insert a new element again, the top is again incremented, then only we are inserting a new element. In this way, the stack is going to be stored the first inserted element at the bottom, and the last inserted element will be the top position. For example, if I want to insert a new element 30 into the stack, which will be placed here, which is 30, and the top, actually the top will be first incremented, then we are inserting 30. So in this way, the elements will be inserted into a stack. Now let us see how the elements can be popped out from the stack. This is the example. Let us see, here is a stack which is having a 2 elements. The top element is a 20 and the bottom element is 10, right? So if I want to pop the element from the stack, which is a 20, what we have to do? Just we have to decrement top. So initially the top was 1, so after deleting the element from the stack, the top will be 0, and the top of the stack will be 10. Again, if I'm trying to delete element from the stack, so we have to decrement the top first, which is a -1, then automatically the element was deleted from the stack. So when the top was -1, which indicates the stack is empty. Let us see. Actually, the implementation of a stack is mainly categorized in 2 ways. One is static implementation, another one is a dynamic implementation. The static implementation can be implemented through arrays only, because the arrays are in fixed size. If you want to implement an array, we have to provide the size first. Based on the size we are providing, the memory was allocated. So for example, if you want to implement a stack using arrays, let us take int stack of 50. So we are creating an array of size 50, which is created with a 50 allocations. Okay, so we are here we are created one variable called the top, initially -1, so the stack was empty, and when I'm trying to insert a new element into the stack, we have to increment the top first, so that the top will be pointing to the 0th index, then we are able to insert a new element into the stack. In this way, we can insert elements from the bottom to the top. And but what is the difference between a static and dynamic is, once we are using arrays to implement a stack, because of the array was in fixed size, so we are not able to increase the size of array when we want to insert more elements. For example, we have created an array for 10 elements, but unfortunately we have to insert more than 10 elements, which is not possible. Once we create an array, we are not able to enlarge the size of array. Or if you are created an array for 50 elements, for example, if you are storing only 10 elements, the memory will be wasted. So that is the main drawback of creating stacks using arrays. So we are moving to the dynamic implementation part. If you want to implement a stack using dynamically, we have to use a linked list. I will let you know in the next class. Okay, so let us see first how we are implementing the stack using arrays. Yes, so when we are using arrays to implement a stack, there will be 2 conditions. One is stack underflow and stack overflow. When we say stack is in underflow, as I said, array is a fixed size, right? So as I said, array is a fixed size. Whenever the elements are not present in the stack, we can say the stack is empty. So if you want to, in this situation, when the stack is empty, if you want to pop an element, or if you want to see the top element of the stack, which is not possible, right? So that situation is called underflow condition, when the top is equal to -1. The top is equal to -1 indicates the stack is not having any elements. When the stack is not having any elements, definitely we are not able to remove element, or we are not able to view the top element of the stack. So that situation is called stack underflow. In coming to the next point, stack overflow. So as the array is having a fixed size, for example, this array is having 1, 2, 3, 4, 5 size. So I am already inserted, for example, just imagine, I already inserted 5 elements like this. Now the top is here, where the top index is 0, 1, 2, 3, 4. Now the top index will be 4, right? So as I said, when we call the stack is in overflow condition is when the top is equal to max -1, where max is the length, the size of the array. Here the size of array is 5, so 5 - 1, which is 4. When the top is equal to 4, which indicates the stack is already gets filled. If you want to insert more element, like 14, if I want to insert a 14 into the stack, which is not possible because the top is 4 now, where 4 is a max -1. So which indicates stack is already gets filled. So this situation is called as stack overflow. So these are the two conditions we have to take care of while we are trying to implement a stack. Next, let us see what are the operations we have on this stack. Basically, the stack is having 3 operations. One is push, pop, peek, where the push is an operation which is used to insert an element onto the stack. The insertion and deletion, or whatever it may be, the displaying top element. So whatever the operations we are doing on the stack will be basically based on the top index only. Okay, so here the push is an operation which is used to adding a new element onto the top of the stack, which is called push. Okay, and coming to the while we are trying to insert a new element into the stack, definitely we have to check the condition called overflow, because as I said, when we are not able to insert a new element, because when the array gets filled, I mean when the stack was completely filled, we are not able to insert a new element. So when we are trying to add a new element onto the stack, every time we have to check for the top index. If the top index reaches to the max -1, then we can say, the push is not possible onto the stack because the stack is already overflowed. So while we are implementing a push operation, we have to check for the condition called overflow. Next, the same way, when we are trying to pop an element from the stack, we have to check the condition for underflow, because when we want to remove, or when we want to pop an element from the stack, the top must not be equal to -1. Why? Because when the top is equal to -1, which indicates the stack is empty, so that we are not able to pop an element from the stack. So for every pop operation, we have to check for the condition called underflow. The same way, actually the typing mistake, which is a peek. The peek is an operation which is used to find out what is the element at the top of your stack. So which returns only the top of the stack, which is not adding an element into the stack, or which is not used for popping element from the stack, which is only used for viewing what is the element placed on the top of the stack. Okay, and in this case also we have to check for the condition called underflow, because if we have at least one element on the stack only, we are able to view the top of the stack. If even though if the stack is empty, we are not able to view what is the top of the stack. So that in this case also we have to check for the condition called underflow. So based on this working process, we have to implement the algorithm, and based on this algorithm we are going to implement a program. Okay, let us see. The push, as I said, the push is an operation which is used to add an element. Fine. So while we are trying to add an element into the stack, we have to check the condition for overflow, isn't it? Now let us implement algorithm for the push operation. The first one, once the very first what we have to check for the condition whether the stack is completely filled or not. If it is filled, what we have to do, you have to come back from the operation. We are not doing anything because we are not able to insert new element when the stack is full. And if it is failed, just imagine the condition was failed, which means we are able to insert a new element onto the stack. So first what we have to do is, you have to increment the top first. After incrementing the top, then only we are able to insert a new element. Let us see some example like this. Initially, top is equal to -1. Top equal to -1. If I want to insert a 30 onto the stack, the first condition was stack is full. We have to check for this stack is full or not. The stack is empty now, so we are able to insert. So what we have to do, you have to increment top value by 1. After incrementing the top, we have to insert value onto the stack. So this is algorithm. And next, so based on algorithm, this is the method. Let us see. The push is an operation. Yes, I created a name as a push, and which is taking an element which is value, which is a parameter, and which is not written anything because the function is not going to return anything, which is used to insert element onto the stack only. The very first, as I said, as the algorithm is having the first one, what we have to do, you have to check for the condition. Yes, here I'm checking the condition. What is the condition for overflow? The top equal to size -1. If the top equal to size -1, I'm printing that stack is full, insertion is not possible, and moving out from the function. If it fails, I'm moving to the else part, and top is going to be incremented, and based on the top value, I'm inserting a new element, and then I'm printing that inserting was success. The same way, we can create an algorithm for the pop operation. So pop is an operation which is used to remove an element from the stack. So while removing an element from the stack, we have to check for the condition called overflow. So what is the overflow condition? Overflow condition is top equal to -1. So that very first we are checking for the stack is empty or not. So based on this condition, we are checking the stack is empty or not. If it is empty, we are moving out from the function. Otherwise, we are just decrementing the top. We are not doing anything. Just if we decrement the top, automatically the element was deleted. Let us see how it is going to be implemented in the programming part. So this is the method how we are implementing for removing element from the stack. So pop is a function name, and which is not written anything, and which is not taking any parameter as well. The first condition was top equal to -1. Because of this condition, we can say the stack is empty. So in this case, we are not able to delete an element from the stack, so that we are printing the stack is empty. Deletion is not possible. If the condition fails while doing pop, which means we are able to delete at least one element is there in our stack. So that what we have to do, first we are printing the top of this stack, because which element is going to be deleted we have to mention, right? So that I'm printing the top of the element, and then we are decrementing the top, so that we are not able to view the top. Next, coming to the peek operation. As I said, the peek is an operation which is used to view the top element. So the algorithm for it is just we have to return the top. But here also we can implement two clauses. If top equal to -1, print stack is empty. Because while we are viewing the top of the stack, if the stack is empty, we are not able to view the new one, so that we can implement this condition also. If it fails, else we can write just we have to return top index. In this case we have to return -1. So -1 indicates there is no elements in the stack. So this is the function called, if the top equal to -1, we are returning -1, which indicates the stack is empty now. When the stack is not empty, we are returning the top element. Clear? And next is empty, which is an extra one, and we can implement more like this. So if you want to know what is the stack status, is the stack is empty or not, we are implementing the stack empty is empty function. So which returns is the stack was empty or not. Okay. If the top is less than 1, we are returning true. Otherwise, we are returning false. Okay. This is the function. And so, as I said, array is used to implement. I mean, array. We can implement the stack using array also, but there are some situations which are not effective for using arrays for implementing stack. Those situations are, as I said, if we create an array for the stack, if we create an array for a stack with a large size, and we are using only few elements to store, so in that case we are having problem called memory wastage. Otherwise, if you are creating an array for implementing a stack, and we are trying to store more elements than the array size, definitely there is a chance of getting error, that insufficient memory to insert new elements. So because of the array was in fixed size, so we are not able to insert new elements. So because of this situation, we are moving to the implementing the stack using dynamic approach. So dynamic implementation is also called a linked list representation. Through linked list, we have to use a linked list implementation for the stack. Okay. In the next class, we are going to discuss about a dynamic implementation. Let us see the demo. Actually, we have discussed about how the stack will be worked and everything, and normal manner, right? So let us see how it works in a visualization. Control పట్టుకోం. Yes, let us see. For example, this is a stack I'm going to implement. Okay, so for that, what I did, I have created some array with a size of 29. Initially, I have taken the array of size 29, so that the array was fixed right now, and I want to insert a new element into the stack. So the top is here. Here top initially 0, so which is not having the top equal to 0 means the stack is not having any element. Suppose, let us understand by inserting a new element into the stack. Let us take, I'm going to insert a new element which is 45. If I'm trying to insert new element onto the stack, the top was incremented first, then only the 45 was inserted. See, I'm going to insert a new one more element. Let us see. I'm going to insert a new element which is 85 onto the stack. So as I said, the push, when the push operation was done, what we have to do, you have to increment the top value first. When I'm trying to insert, the top was incremented now, then inserted, the top was incremented, which is 2. In this way we can insert elements and we can pop elements just by decrementing a top. And if I decrement another new element, the same thing, just we are removing element by decrementing the top. Okay, so in this way we are able to insert new element into the stack, we are able to remove elements from this stack. Okay, so this is how actually the stack was working, right? And let us see, continue with the next class for how we are implementing the stack using dynamic implementation. Fine, bye.